Good morning, students. Welcome to today's further maths class. Today is Tuesday, the 23rd June 2020. Our topic today is derivative of trigonometric functions. We have concluded the derivative of algebraic function. In this trigonometric function, we have basic trig ratios, which is the sine, the cos, and the tan. Their inverses are cosec, that of sine is cosec, that of cos is sec, and that of tan is cotangent. We will be looking into the derivative of the three. It has been established that if y is a function of sine x, then dy dx is cos x. Also, it has been established that if y is a function of cos x, then dy dx, which is the derivative of cos, is minus sine x. Now with these two, we can go ahead and derive the rest of the trigonometric functions. So the first example, if y is equal to tan x, we want to show that dy dx is sec squared x. What this invariably means is that the derivative of tan is sec squared. So let us prove that this is equal to this. Solution: in this equation, y is equal to tan x. It implies that y is equal to sine x over cos. In our trig ratio, we know that tan x is equal to sine x over cos x. So we let u to be equal to sine x, equation 1, and v equals to cos x, equation 2. Because this is a rational function, we are going to use a quotient rule. So immediately I let u to be sine x and let v to be cos x. So that will make this equation become y is equal to u over v. That is equation 3. Therefore, dy dx will be v du dx minus u dv dx over v squared. So from this, we're going to find derivative of u with respect to x and derivative of v with respect to x. So in equation 1, du dx, it has been established that when you differentiate sine x, it will give you cos x. So that will give you cos x. Note it. When you differentiate v with respect to x, to give you minus sine x. So we have this, we have this, we have this, and this. They are what you need in this expression. Therefore, dy dx is equal to v is cos x, du dx is cos x, minus u is sine x, and dv dx is another minus sine x, all cos x all squared. So this will become cos square x minus times minus is plus sine square x. Please note that sine x all squared is the same thing as sine square x. This expression should not confuse you henceforth. They are the same. So the denominator will be cos square x. Now remember the identity for cos square x plus sine square x. That will give you 1. So the numerator is 1. That will give you 1 over cos square x. Now recall the inverse that I gave you, I quoted earlier, that 1 over cos is sec. So this one will give us sec square x as required. Hence, dy dx is equal to sec square x. So this is how to derive the trig ratio function. Now the second example here, if y is equal to sec x, find dy dx. Solution: I didn't give you a guide in this one. Unlike the previous question, I asked you to prove so you know where you were going to. For this one, you have to find y dx. Y is sec x. The only identity that I know in trig function is if y is equal to sine x, I know that dy dx is cos x. I know this. And I know that if y is equal to cos x, then dy dx is equal to minus sine x. So this one will prompt me into changing this to either sine or cos, because it's an inverse of cos precisely. So that will lead me to changing this. So y becomes 1 over cos x. Now, if you like, at this point, it's a rational function, but the numerator is 1. I can decide to use quotient rule, or I can decide to use function of a function. But I think we are familiar now with the quotient rule. Let's use quotient rule. So u is 1, v is cos x. So du dx is 0. When you differentiate a number without x is 0. In other words, when you differentiate a constant is 0. Then this dv dx is minus sine x. So I have this, I have this, I have this. These are the 4 variables in the formula. Therefore, dv dy dx is equal to v du dx minus u dv dx over v squared. So we have dy dx to be equal to our v is cos x, our du dx is 0, minus our u is 1, our dv dx is minus sine x, all over cos x all squared. So from here, cos x times 0 will give you 0, minus times minus will give you plus sine. So dy dx is equal to sine x will be at the numerator over cos square x. The denominator is cos x all squared. So if you look at this, you need to know trig identity in order to resolve this. This is sin x over cos x times 1 over cos x. You can see this. This is tan x. 1 over cos is sec x. So this is sec x. So it's either you read it as tan x cos x sec x or sec x tan x. So this is the derivative of sec x. If you ask to find the derivative of sec x, it is sec x tan x. And now I will give you your own question to solve. You are going to derive the rest of the trig identity. Okay, this is your classwork today. Find the derivative of the functions y is equal to cot x, y is equal to cosec x. These are the two remaining trig identities. The two I've given it to you direct, and I derived 2 here. So the remaining 2 is for you. Please derive it, follow the steps, and you can contact me if you are lost, or still you can watch the video over for guide. Thank you for watching. God bless you.